RNA polymerase is on a road trip to transcribe prokaryotic genes across the entire genome. RNA polymerase cannot do it alone. There is a long road trip ahead. It's going to need regulatory proteins, which have been coded for by regulatory genes long before the RNA polymerase was set off on this road trip. One can think of those buildings in the background as the many protein formations that are possible with DNA transcription. It's important to know which buildings are to be built and which buildings are not to be built, so you're not wasting energy, and so that a purpose for every building. That's why there are activator proteins that will help make sure that the builders come to the right place. RNA polymerase is off course and is looking for the road to transcribable DNA. Right ahead, a sign that says promoter region this way. RNA polymerase is stoked and cuts a sharp turn towards a sign into the distance, ready to transcribe some DNA. In this situation, the sign acted as the activator protein that will positively control transcription. It recruits the RNA polymerase to the promoter region of the DNA that RNA polymerase will recognize as the transcription start site. The genes that will be transcribed are the structural genes, and they could be multiple genes coded by a single promoter region. That will make many different buildings just with one promoter region. The promoter region is the landing pad for RNA polymerase. However, the activator binding site is on the operator region of the DNA that is farther down the genetic code than the promoter region, which is where the RNA polymerase will bind. The operator is the landing pad for the regulatory protein, such as the activator or the repressor. In this case, the sign is the activator, as it recruits the RNA polymerase to the transcription start site. There are other factors that influence the RNA polymerase's ability to transcribe the genetic code. There are small molecules or effectors that can also control how much DNA gets transcribed. The effectors in this situation are the lights on the sign. In a positive inducible scenario, the lights on the sign are acting as the effector because it is allowing for the activator to be active. Without the lights, the sign would not be functioning properly, and then the RNA polymerase would never see the path to RNA transcription. And similarly, without the effector substrate, the activator cannot properly bind to the operator region and signal the RNA polymerase to the transcription start site.